Okay, so we're still looking at volumes of solids of revolutions, but there's going to be a slight difference between our solids today versus yesterday. So let's get started. I have y equals the square root of x plus 2. I have y equals 3x. I have x equals 0. And we want to rotate this around the x-axis.
You said this was still revolution?
Still, yes, still volumes of solids of revolution. Alright, so let's see what this thing looks like. I have x equals 0, which is going to be the y-axis. I have y equals 3x. What do you know about y equals 3x? Yeah, it's going to have it's going to start at the origin. It's going to go up 3 and over 1. So we're looking like that. And what do you know about the square root of x plus 2? Half parabola.
Up 2.
Starting at positive 2. Okay, and let's go ahead and plug in 1. What happens when I plug in 1?
Yep.
I get 3, so that means it's going through that point right there. So that means our little piece we're going to rotate is right there. So we want to rotate that around the x-axis. So let's get started just like we did yesterday. What do I need first? Limits. What are my limits?
0 to
0
what is it?
0 to 1. What can I do to make sure it's 1, even though I've kind of verified it already? I can set them equal and solve. What else could I do to verify that it's 1? Plug in 1 to each of them, I should get the same number. So if I plug in 1 to this first one, what do I get?
3.
I plug in 1 there.
3.
Since I got the same number, that tells me they intersect there. All right, so then what do I need? The area formula, what's it going to be? Pi r squared. Okay, and that's where we need to change slightly what we did yesterday versus today. What's different about this little section versus what we did yesterday?
It's on the y-axis.
Say it again.
It's on the y-axis.
All right, it's kind of touching the y-axis. What'd you say?
It's not similar. It's like,
I don't know. Just like it's not the base.
All right, so for instance, one of the ones we did yesterday, we had this, and it was what we wanted to rotate
It won't be the radius.
look like that. Okay, what's different about this and what I have today?
that one's not touching it.
Very good. The keywords I like to use are constant contact. Okay, is the region you're rotating in constant contact with what you're rotating around? So yesterday's stuff, what do you notice about my region? It's always touching the x-axis. It's always in constant contact. But on today's, this little region, I'm rotating around the x-axis and I'm going from 0 to 1. Am I always touching the x-axis? No, I've got a gap. I've got a gap in here. Okay, I've got a gap in there where I'm not touching. Okay. So what do you think that does to me when I'm finding the volume? What am I going to do to find the volume?
You're gonna find the whole thing.
I'm going to have to do some subtraction. Logan, what did you say?
Find the whole thing and subtract the bottom.
Find the whole thing and subtract the bottom. So we're going to find the area, or the volume, sorry. We're going to find the volume of all that rotated, and then we're going to come in and we're going to find the volume of that thing rotated, and then when I subtract those two, that gives me the piece that I'm looking for rotated. Everybody follow me?
But you said you find the volume of the whole piece, and then what was the second one you had to find?
The volume of
The one
the,
that's touching the
right, the volume of the piece underneath. So what needs to be done differently? What's going to be different?
The 2 4
I'll have 2 what, Alex?
intervals.
I couldn't hear you.
Intervals.
All right, 2 intervals. What am I going to do with those intervals?
Add 'em.
Or subtract.
I'm going to subtract them. And if I've got two integrals, what do you think I'm going to have two of as well? Two R's. That's the key. Very good. What we need to realize is that if I am not in constant contact, I've got to have two R's. Yesterday, I was in constant contact. How many R's did we have? One. If you're not in constant contact, you need two. If you are in constant contact, you only need one R.
They're ever gonna be three.
No, just two.
I
All right. So, I need to get my first R ready to go. What's my first R going to be?
Square root of x plus 2 minus 0.
Square root of x plus 2 minus 0 is correct. Everybody okay with that? What's my second one going to be?
Square root of minus 0.
3x minus 0. Very nice. Those are my two R's. Any issues?
Wait, you did 3x minus 0?
3x minus 0. My two R's, I need a radius that goes from here all the way down to here, and then my other one goes from that underneath piece to there.
We don't have to go right to left from there.
If what you're rotating around is horizontal, you got to do top minus bottom. If what you're rotating around is vertical, then you got to do right minus left. All right. So then we're going 0 to 1. I've got pi. I take the first one, square root of x plus 2 squared, and then I'm subtracting the other one, pi 3x squared dx. Okay, what do you want to do from here? Take the pi's out. And yeah, go ahead and square it. So this is going to be x plus 4 square root of x plus 4 minus 9x squared dx. And this is where I'm going to stop on the notes. We're not going to spend time integrating and plugging in because that stuff is not new. Getting to this point right here is the new stuff. That way it saves us time. We can do more examples. How many points are left to be had after this point?
1,
2. 2. Where's the first one come from?
Integrating.
Integrating and plugging in. So there's 2 more points to go from here. Integrate and plug in to get your other 2 points.
If we have to do how many more examples, is this gonna get really hard?
No, it's not really hard.
Is it hard?
No. That right there, it doesn't. If you can handle that, you're good to go.
Alright.
All right, now let's take this same example. Let's take the same example, except instead of rotating around the x-axis, let's rotate around y equals -2. So y equals -2 is going to be somewhere down here. I want to take that same thing and rotate it around y equals -2. So do my limits change?
So do we just completely ignore
The x. No, it's no, x equals 0 is still there because that is the left side. X equals 0 is the left side.
the limits don't
Say it again.
the limits
The limits do not change. That region is still that region.
the radius.
The radii will change. So I still need 2 radii. Why do I need 2 R's?
Not constant.
It's not in constant contact. In fact, in this case, it doesn't touch at all, does it? Okay, because we're rotating around y equals -2, it does not touch at all. So who can give me the first R? Alright, so square root of x plus 2 minus a -2 gives me my first R. Everybody on board with that? Because my R is going from the top, except in this time, instead of stopping at the x-axis, I'm going to go all the way down to there. So to get that distance, I've got to do top minus the bottom. My top is the square root of x plus 2. My bottom is -2. So that's what I did there. What does my other R need to be? 3x minus a -2 gives me my other R. And it's just a matter of plugging in and integrating. So we go from 0 to 1, pi. This ends up being square root of x plus 4 squared minus pi 3x plus 4 squared dx.
Why is it plus one?
Plus 2, sorry.
This is fucking.
Pull the pi out, multiply, integrate, plug in. So if you get to this point, you've got at least half the points. If you're doing this by hand, this is worth 2 points. If you're doing it with the whole thing would be worth 4 points if you're doing it by hand. If you're doing it with a calculator, the whole thing would be worth 3 points. There's only one more point to get, and that is I just plug this into my calculator to get the third. But when I set it up, I get 2 points out of this setup. All right, next one.
Switch to the first one.
So I have the region bounded by y equals 4 minus 2x, y equals x squared plus 1, and x equals 0. I only want the piece that's in the first quadrant, and I'm going to rotate that around y equals negative 3. Alright, so x equals 0 is going to be the y-axis. That's the y-axis. 4 minus 2x, what do you know about 4 minus 2x?
Starts at 4.
Starts at 4,
Down to
down 2 over
over
1, down 2 over 1. So there's that. It said we have to be in the first quadrant, so that's the only piece I need of that. And what do you know about x squared plus what?
parabola that starts at 1.
Parabola that starts at 1. I only need to go to the right side. Where do you think that's going to go? Where do you think that's going to end up at with that line?
At 2, 1.
At 1, 2?
Yeah.
And what can I do to make sure that matches up?
Plug in.
Plug in 1. So if I plug in 1 to 4 minus 2x, that gives me 2. If I plug in 1 to x squared plus 1, that gives me 2. So that tells me they do intersect right there. So we want to rotate this piece right here around y equals negative 3. Alright, so what do I want first? Limits. What are my limits?
0 to. Is that 2?
0 to 1. Because we just plugged in 1. That point is 1, gives me the y value of 2. So 0 to 1. Then what?
Here.
Area formula. What's my area formula? Pi r squared because I'm rotating. Alright, and then I need to ask myself what?
How many R's?
How many r's do I need? How many r's do I need? I need 2 r's. And why do I need 2 r's?
It's not in
Constant contact.
I'm not in constant contact with what I'm rotating around. So what is my first r? 4 minus 2x minus negative 3. And what's my second one? X squared plus 1 minus negative 3. So we integrate from 0 to 1, pi. This ends up being 7 minus 2x. I square it. I've got another pi. And that is x squared plus 4 squared dx. And I'm set up. We can just earn 2 points.
So if you found like the volume of all of that, would you have to extend the 2x, negative 2x line? Or would it just go straight down?
No, it would go straight down from right there. So this right here the volume of that right there is that piece. And then the volume of this other piece would be the under part. And then when I subtract those two, that gives me the volume of that rotated. Alright, then let's make an adjustment on this one. Let's make it around y equals 5. So y equals 5 would be somewhere up there. So my limits are going to be the same, my area formula is going to be the same. Do I need 2 r's or do I need 1?
Two.
I need 2 r's. Why do I need 2 r's? Not constant contact. There's a gap. If there's a gap, I've got to have 2 r's. Alright, so let's see if you guys do a little bit better in third hour. What's my first r?
4 minus 2x minus.
Anybody else want to take a shot?
X squared plus 1 minus 5.
Anybody else want to take a shot?
5 minus 4 minus 2.
Very good. No, you're a little bit off. You're closer though. You had the right idea.
What is that?
5 minus
5 minus x squared plus 1 is going to be my first one.
That's
Because my radius, the top of it is going to be here, and the longest radius goes from there to there. So the top of it is 5, and the bottom of it is that parabola, which is x squared plus 1.
What did Justin say first? 5 minus.
He did 5 minus 4 minus 2x,
Why is it not that?
because that gives me the shorter one.
Oh, you want the longer one first?
The longer one always has to come first, because the longer one produces the bigger volume, and I got to have the bigger volume first. Okay, if he did it backwards like that, what would happen?
You're not gonna get
He'd get a negative volume, and that would tell him, well, I need to go back and switch.
so the other one is 5 minus 4 minus 2.
That is correct. The other one is 5 minus 4 minus 2x. So then I just set it up. We're going 0 to 1. Pi, if I clean this up some, it would be 4 minus x squared, squared minus pi. Clean that up some, it's 1 plus 2x squared dx. So there's my setup. That gets me 2 points. Question on that?
How did it, I don't get the radius thing, no longer, what were you saying about no longer?
Well, I don't know if anybody's noticed, but what is always a part of your radius? What's the same in both my radii here?
The one it rotates around.
What it rotates around. The 5 is the same. So what I'm rotating around is always a part of your radius, whether or not you're doing today's stuff or whether or not you're doing yesterday's stuff. Okay? What you're rotating around is always part of your radius. So I know 5 has to be involved. And it's a matter of whether or not the 5 comes first or the 5 comes second. How do I tell whether or not it comes first or second?
If it's
If the line is above my region, then it's got to come first. If the line is below my region, then it's got to come second. The other thing is, then how do I tell which one of these do I use first?
number.
Whichever one is furthest away from my line. So since this right here, since that is further away than that piece, that means it's got to come first because it produces the longer radius. The longer radius always has to come first because it produces the largest volume. And again, if you can't tell, what do? You just go with it. And if you get a positive answer, what's going to happen? If you get a positive answer, that means you did it right. If you got a negative answer, that means you need to switch.
I thought it was gonna be a technique or something.
No.
Let's go with that.
Just
Alright.
if I'm doing this,
That's fine.
if I'm doing this, I know 5 has to be on both of them and 5 has to come first. Do you agree with that? Why does 5 have to come first?
This is on top.
Because it's on top. And then if I can't tell which one of these needs to come next, I'm just going to pick one and go with it. And if I get a positive answer, that means I picked correctly. If I get a negative answer, then I need to go in and I need to switch these two. Okay?
But I was gonna be like subtracted.
It's always subtracted. It's always top minus bottom. Now, if my line is below, then I pick one of these to come first, and then I subtract whatever my line is. Okay? If I get a positive answer, I did it right. If I got a negative answer, that means I did it wrong. That's all there is to it. Got it?
Yep.
All right, let's do one more, and this time let's rotate around something that's vertical. So I have y equals the square root of x, y equals x squared, and this time I want to rotate around the y-axis. Alright, so let's graph what I've got, which gives me this. What do I know about the square root of x? Half parabola, so it's right here. It's going that direction.
It doesn't start at 1.
Does not start at 1. If it started at 1, what would it look like?
Plus or
So you would
minus.
have a plus 1 that's outside the range. Alright, what do you know about x squared?
Whole parabola.
It's a whole parabola. Where does it start?
Origin.
At the origin, so that's going that direction. So where's the region I'm looking for?
That little
And a little piece right here. So that little piece right there is what I'm looking for. But this time it's different because I'm going around the y-axis. So what has to change?
You have to make it x.
I need to get x. I need to get it in terms of y, which means I've got to solve for x. So on this first one, y equals the square root of x. What's that going to look like?
X equals y squared.
All right. And for the other one, plus or minus the square root of y. Which piece do I want? I want the plus. All right. So there's that. What's next? My limits. And what do my limits have to be? What type of limits do I have to have? I've got to have y values, which means I've got to go from the bottom to the top. So I've got to go from the bottom to the top. What's the bottom?
0.
0. And what does the top look like? 1. What can I do to make sure it's 1?
Plug in 1.
Plug in 1. So if I plug in 1 here, what do I get? 1. If I plug in 1 there, what do I get? 1. So that means 1 is correct. Alright. Then what do I need? Pi r squared for my area formula. Then what? How many r's do I need?
2.
2.
Even if I touch it,
There's a gap. There's a gap in here. It's not in constant contact.
okay.
It can touch, but if there's a gap, that means you need 2 r's. Alright. Now, since I'm going around something vertical, how am I going to get my r's?
Right minus left.
Right minus left. So which right one do I want first?
With the x squared.
Third.
Right, I want the one that's a parabola. The parabola is this one, so that means I want square root of y minus 0. Okay, and the other one is the half a parabola, which is right here, which means I want the y squared.
Why is it not 0?
Because we are rotating around something that's vertical. In this case, it's the
Oh.
y-axis. But we're putting it here because in a second, we're going to change it from the y-axis and change it to something else.
In the middle of this problem?
After we get this set up, then we're going to come back and change it,
Gotcha.
rotate around something.
Thinking that, like, turn this
All right, so now we're ready to go. We're going from 0 to 1. My first r is, I forget my pi, square root of y minus pi. The second one is y squared squared. There it is. I'm set up. Questions on that? Alright, so then now let's change what we're rotating around.
So you either rotate forward.
Alright, so let's come over here. Let's rotate it around that. Let's say that is x equals negative 3. So I want to rotate that piece around x equals negative 3.
You make a plan. Yes.
Do I need 2 r's or 1? 2. Because this time I have no contact with what I'm rotating around. Alright. Then does the negative 3 come first or does the negative 3 come second? Comes second, because how do we do it?
You're going right to
We
left.
do right minus left. So since it's on the left, that means it's going to come second. So I know I'm going to have a minus 3, or minus a negative 3 on both of these. Okay, now I need to choose which one is furthest away. The parabola or the half parabola? The parabola is furthest away, and that goes with the square root of y, which means y squared goes there.
So it's just like,
So we integrate from 0 to 1. I have pi. This would be the square root of y plus 3 squared minus pi y squared plus 3 squared dy. I'm set up.
Quick question on the limits. If you like have no clue where the other one is, like you can't even guess which one, is there a way to find it?
Set those two equal each other. Maybe I'll give it to you. If I did y squared equals the square root of y, what do I need to do next? Square it. Excuse me, that, then what? Then what? And when I solve that right there, what am I going to get? I'm going to get 1. That's where I get it. Alright, so then what do I want to do next for the last one? What do I want to change? Couldn't hear you. Yeah, very good. Good, Sam. So now let's move it over here, and let's say we want to rotate around x equals 6. So, no contact at all, so that means I need 2 r's. And this time, is the 6 going to come first, or is the 6 going to come last? First. It's going to come first. So both of them are going to be 6 minus. Alright, so which one is going to produce the longest radius? The half parabola, which goes with y squared. Which means square root of y has to be there. So we integrate from 0 to 1. I've got pi 6 minus y squared squared minus pi 6 minus the square root of y squared dy. Okay, and just for fun, let's plug this in the calculator and let's mix these up and see if it gives me something that's negative. Alright, so I need, how do I get the integral again? Shift plus, we're going from 0 to 1. And actually, let's go ahead and go out front. What can I put out front? Pi. Let's go ahead and put the pi out front. That way I only have to write it once. Alright, I need parentheses, the first one, and let's switch them. So let's put this one over here first. 6 minus the square root of y. And then minus, let's put the other one second. 6 minus y squared.
I do.
I think we should just get one.
So hopefully when I press enter, what should it give me? Should give me a negative, and it does. So what is the actual answer to this? 11.623 would be my correct answer. So that tells me I need to come back in here, and these two things need to be switched, and that'll give me the correct answer. Okay, so if that ever happens to you, you know how to fix it.
Okay, so question.
Yes.
If you do it wrong on the AP test, if you set it up wrong, but whenever you put it in the calculator and you realize that it's wrong, do you want us to go back and switch it?
You have to go back and switch it.
Even if we write down the right answer?
Even if you write down the right answer, you need to go back and switch it. Alright, so that is finding volumes of solids and revolutions when your region is not in constant contact. So if I'm not in constant contact, I need 2 R's. If I am, I just need 1. That's the only difference between yesterday and today. Whether or not you need 2 or 1. Alright, like I said, tomorrow you'll work on an assignment that covers this. Friday, we'll start doing a review packet to get us ready to go for the exam.
I checked, we still haven't put the Saturday session in.
Are you sure?